Hi everybody. Can you hear me? And look at the cats. Cats are truly enjoying themselves. This is ravioli, and this is pesto. Look at the feeties. I think this is the only electronics focused channel with an obsession about cats. Even the signal path has fewer cat interactions than I do. Yeah, I honestly, I have a phobia of fireworks, personally, and my dog has a phobia of fireworks as well, and I just don't get people who shoot fireworks by themselves. Like, it's very, very dangerous. Okay, so let me put the cats in the corner. Actually, you can still see them. Um, so I've been locked in this room with the cats, and it is my duty to present to you some um, HP gear, right? Because I promised. Um, so as you might know, I did manage to finally get a 3458A. It's a beautiful HP model. It's been fully restored, recapped, Ray Schaffner filtered, calibrated, verified, everything. It's just gorgeous, and I'll show it to you a bit later. And I didn't get it for free, by the way, so this is not a paid promotion by any means. But I had such a pleasant experience with purchasing this unit that I need to share my experience with you guys. So I got it from AB Precision. I'll link it in a pinned comment after the stream is done. The lovely chap named Adrian Bernhardt, who was a aerospace engineer back in the day, decided to set up a calibration lab basically of his own. And he also deals in used precision test gear. So he's got everything from voltage standards, HPs, Solartrons, Datrons, calibrators, capacitance standards. He's even got the Andine Hangerling ultra precision capacitance bridge. That might be a spoiler. I'm not yet decided. And I promise I will do a more in-depth video about the HP, but that is when I get the Kelvin Varley voltage divider that I got from him, and when I get the Fluke 731 first. So I got a bunch of stuff thanks to Adrian. The 731 wasn't actually his, but he hooked me up. The KVD is a Fluke 720A model. I'm going to link it in the pinned comment as well. And I'll basically have to repair the Kelvin Varley a bit first, because I think there's a loose contact or something inside. I went through the schematics a bit, and considering what Adrian told me about the unit and the schematic, I don't think that I'm unlucky enough to have a dead resistor or something like that. I think I just need to, it's not here yet, but when I'll get it, I'll do a proper video checking it and I haven't done a video in a while because this camera that's shooting from overhead doesn't really do 4K the way I like it. I tried it, but yeah. And I don't want to go back to the phone. I'll see. Regarding what Nini asked, reverse engineering the 34410. Is that like an improved 34401? I have no idea. I've never heard of that meter. So, plan is for the next period. So Kelvin Varley, a Fluke 731A voltage standard. I think it's based on the same SZ8263 Zener with a matched NPN transistor, and I want to change the power supply in that thing because it's apparently not good enough for operating, like not good enough. It's way too leaky for measuring while it's connected to the mains, so you have to disconnect it and measure it on battery power, and that's not great. So I want to change the power supply in that. And then I want to fix the Kelvin Varley and see how that goes, because Kelvin Varley dividers are very, very interesting. And I had quite a lengthy chat with a Fluke service rep internationally in the United States, and when I heard about the prices for just a evaluation for the unit, let alone the cost of a brand new 720A Kelvin Varley, it's just, oh my god, you could buy several calibrators for the money they want for one of those units. So sending it to Fluke for an authorized repair is completely out of the question. And finally, I hope by the end of the year I'll have at least a prototype of my multi-slope. I'm getting close, and but it's almost 7 o'clock, so we should really start looking at some HP gear. And as I said, I'll leave the best for last, honestly. So we can start with a thing that a friend asked me to fix, and that might lead to some more interesting equipment in the future for this channel. Hopefully. The king of rambling. Oh, thank you. I appreciate it. I know you mean well. Apologies to the headphone users out there. So, looking from the top, I don't think you could tell exactly what this thing is. I promise you it's an HP. And it's a audio analyzer. Hi, Aramir. It's an audio analyzer. It's made by HP. It's beautiful. It's very LGBT, and I took the top off so I won't bother you guys with disassembly and reassembly and everything like that. So this belongs to a friend who works for Trescal, Romania. I think you know about Trescal. They're basically Denmark's Institute of Metrology, something like that, and they're a private entity. They have quantum halls, they have Josephson junctions, they have the guy that told me about the Brulin Care I mentioned in the last video, and they do all sorts of calibration services here too. So at work we use them for calibrating all our stuff. So he had this unit die on him basically during a job. Is it in the right order? I think it even is in the right order, right? Yeah. It's very funny that it's rainbow colored, and in the schematic they actually describe the boards by the color of their latches. So it died on him during a job, and the he shipped it in a giant shipping crate, and the cats were very interested in the shipping crate, of course. And I took it out of the box, let it warm up, turn it on, let it warm up inside, and took a good hard look at it, realized that there's something wrong, and then I took it apart to the state that you can see here, and I decided to take a look at the first board, which I was expecting a very complicated repair, because these things are usually like, look at this, and it's a whole rainbow of boards inside. So I looked at the first board in here, and made by HP in the United States of America, and yeah, everybody's already here. And I saw, so first of all, this board is called the input amplifier. It is a true joy to give maintenance, to perform maintenance on HP gear from this era. So first, this quick sidebar, because I'm the king of sidebars. Keysight, who separated from Agilent, who separated from HP, actually still have the manual for this unit. It's the 8903A. They still have the manual on their website, but guess what? The manual that Keysight has on the website doesn't have the full schematics. But if you Google the model number and go to the second link on Google, there's a full manual. It's like a couple hundred pages, and full schematics, troubleshooting procedure, error indications, or everything. It's beautiful. Depressing that Keysight don't have the full manual, like Stanford Research don't have the full manual for their lock-in amplifiers or any of their older tools. But anyway, and I took a look in this area, and I saw a couple of fuses, and I went like, well, this has got to be some sort of input protection, right? Like AC coupling capacitor, maybe some range switching relays, I don't know what. And I took this one out. This is the replacement, correct replacement now. Took this one out, measured it. Actually, first of all, I looked at it completely open. Looked at this one, it's a light bulb. So yeah, this came from, I think you can see the company name here. I don't know if it's been opened before. The correct fuses are in the mail, because I only had 1/16 amp fuse. But just look at this. This is I think it's not even a fuse. I think it's a light bulb. Yeah. So this is obviously the input protection for the thing, and it did its job. It protected the device from an input overload, and of course, because it protected the input was floating, and it did nothing. So just look at all of these beautiful parts, like, and everything is just so nicely labeled. Soft meter, program amplifier, offset, single-ended, common mode. Everything is labeled so nice, even the adjustments for the flatness, and just gorgeous. And let's take a look through these boards one by one, and then I'll show you what the thing does, and I'll try and explain a bit what's going on inside, though I'm not very confident that I'll be able to. So this is a notch filter. Basically, I think this notch filter filters everything around the frequency that the input is looking at. in order to perform distortion analysis and stuff like that, because it can do noise, distortion, THD, and stuff like that. And just beautiful ceramic hermetic packages. Every component, I think the green dot on them means that they're selected. Balance offset, tune offset, tune balance, and everything is described in the manual so wonderfully. Like every procedure, every trim that you can do is just so amazing. Like everything is beautiful, and it's a level of detail that, yeah, not many engineers still practice to these days, to this day. Just look at this. I think these are 2 pairs of matched JFETs, which are thermally coupled by that strap over there. The Sprague capacitors, silver mica. This is a output amplifier slash voltmeter, so this probably is the either a true RMS converter or something like that. Logarithmic amplifier, DC out, etc., etc. Because this thing can measure, so you can feed it an external signal, it latches onto the frequency and measures THD and noise of that signal, or you can use the built-in reference oscillator. And yeah, the connectors are a bit, what do you call them, aged. They're not as nimble as they used to be. And it even has a beautiful thing on the back. It has a pen plotter output, so you can hook this thing up to a old-fashioned pen plotter, and it's got the X output and the Y output and a pen lift, which basically meant when the pen lift was high, it was gonna lift the pen off of the paper so it wouldn't draw when it moved back to 0. This is the reference oscillator. So this is the thing that generates the No, the WhatsApp pings aren't for me. I have everything on mute. I'm sorry. What are you hearing, guys? So this is the reference oscillator, the thing that generates the any frequency from 20 hertz to 100 kilohertz or something like that. Yeah, 100 kilohertz, and you can feed it into your device under test, and it will plot frequency responses and stuff like that, and measure noise, and it's what you would expect an audio analyzer to be. Now, it's not very high performance these days compared to something like a, I don't know, a modernish audio analyzer or something like a Roden Schwartz UPV or something like that, but it's just beautiful. And this is an output attenuator, and you can see these Aromat relays. I think these are quite significant. Like, I've never seen relays this big. These are signal relays, and just look at this. Power resistors. It's just beautiful. These things, I think, are the same family. It's not yours, it's your cat's WhatsApp. We're in a group chat. What the hell? Anyway, you guys are cat fans, right, as well. So I think these are the same family as the Fluke 5700 calibrator. So I'm expecting that these are very old, but they haven't failed yet. Well, anyway, it's not as high precision of an instrument. And this is the last analog board. So that was the output attenuator, and this is the, no, this is the, this is not the last analog board. This is actually the pen plotter. So I'm pretty sure that's just y-axis, x-axis, and probably some sort of a deck to generate the x and y outputs for a plotter or display unit or something like that. Yeah, these connectors are pretty stiff. That one's in. This one's in. Okay. And we have two digital boards. First one has, I think, the main processor and some memory, a crystal oscillator with a big variable capacitor for tuning, I think, the frequency of that oscillator. And these are some status LEDs, because when the unit is operational, depending on what it's doing, you can actually see these through the top. Tantalum capacitor, I'm pretty sure that this is the only living tantalum capacitor I've seen in a piece of HP gear. I'm joking. I actually, every time I have to deal with electronics and services that actually can carry out. What plastic flags? These ones? No, the latch things. Every time I have anything to do with tantalum capacitors, I have a heck of a good time. And yeah, this is an... I have no idea what this is. I think this is the GPIB interface or something like that, because it is actually GPIB programmable. Right, and let me just move the cat camera. You're gonna have to look at something else now. And I'll get a plug. And zoom in. So that's basically what it does. It has a input, an output. This is for the reference generator, and it can do a sweep with the start-stop frequency. This is the source setting, the frequency, amplitude, and it's got the same thing as a calibrator, which I really like. Divide by 10 or multiply by 10 for frequency and amplitude. A keypad, and it's got, apologies, a nice needle movement. What do you call these? I don't want to call it a galvanometer, although that's what it kind of is. And it's got some filters, and it's got a different types of measurements. So it has AC level, synad, and distortion. And if you hit shift, it does DC level, signal to noise ratio, and distortion level. So distortion is in percent, distortion level I think is in decibels. No, that's not a VU meter, god damn it. I don't like the term VU meter. Now let me just quickly show you, looking at its own reference signal. So, oh, it's actually got a pretty nice, fully differential input. And if I set the you can see now the frequency is 10 kilohertz, amplitude is 1 volt RMS. I've checked it against my 3458A. It's pretty close. It's actually reasonably close. It's within 0.1%. And the distortion from the built-in signal generator is pretty good at 0.009%, so 0.01% THD. And let's look at the signal to noise ratio. It's 81 dB. So that's a pretty good reference oscillator. And here it's decent enough for general purpose audio, but if you're an audiophile, yeah, 82 decibel isn't that great. Right, back to the cats. Now, while I take this giant thing off the bench and look at the next HP, I'll just take the cats and put them here. Apologies, by the way, regarding the state of the mousepad. The cats are to blame for the hair on my mousepad. So this was HP number 1. And another bench-breaking device. Her nose is shaped like a heart. Well, she's a very loving cat. Both of them are very loving. They're very, very cute, actually. Alright, let's look at the second HP. Oh, let me zoom out. So, I think you'll barely be able to see this thing as it is. But we'll take a look inside, because that's the interesting part. Whoops. Have you seen one of these in a while? A logic analyzer. So this was actually from the flea market guy. PPM level sensitive whiskers. Yeah, they're very sensitive actually. And her ears are also very sensitive because she gets ticklish right away. This is a 1664A logic analyzer, and both of them are very, so this one is very shy with strangers. The other one hiding beneath her is very open with strangers, which is remarkable because she's the first cat that I've ever seen that is very curious with strangers. So both of them are very easygoing and very lovely. This one actually has fallen asleep on my chest while I'm watching TV so many times that it's just crazy. But they're not hostile at all. Just look at them. Look at their tiny faces. Okay, so let me move this thing a bit and plug it in and move the cat cam again. So you can see the display of this thing, which is pretty awesome. By the way, I didn't the input to the logic analyzer is on the back, which is very convenient. So look at this. It's running, I think it's running some sort of DOS, and it's loading everything off of that floppy drive, and it's very, very slow. And even more than being slow, it's very noisy. And we'll take a look. We'll take a look inside after I show you the booting process. It runs DOS, yeah. So Maine Coon cats. No, none of them are Maine Coon. I'm pretty sure Maine Coon cats love everybody. Um, I also have the floppy disks. It's actually loading. Um, I had still have, arguably, a massive problem with collecting test equipment. Um, I think they use the same format as the 4145. I'm not sure I have a 4145. I don't have a floppy disk for the 4145, so I couldn't change them around and see if this one starts up with the 4145 firmware. So, logic analyzer input is on the back. It's got one of those braided cables. I took it out because it was far too much of a tripping hazard. And imagine actually working on something like a 68K Motorola, or working on, I don't know, a meter, designing a multimeter and having to do all your logical debugging using one of these. I wouldn't want to have had that thing to do with that thing very much. So that's what it looks like. And I'm pretty sure it's DOS. It seems to have a very similar file system to DOS. So if it looks like DOS and smells like DOS, it's probably DOS, right? Spit it out. And imagine actually having to use one of these on a daily basis. Like, I think I would have gone crazy with the noise. Microphone isn't really picking it up, but let me share in the pain. Yeah, that's lovely, right? Okay, so it's packed with functionality, but the interface is a nightmare. Yeah, well, tell me about it. Mine came with the original mouse that plugs into the back. It's got sort of like an RJ45 connector. And I actually even had some swag, and I wanted to tweet something that so if you bought one of these and signed up, you could have won a portable PC, an HP Pocket PC or something like that back in the day. None of the compacts or something like that, but an actual like DOS Pocket PC. And I want to tweet Keysight, hey, is this promotion still valid? I would like to redeem my chance of winning. Okay, so I hope I have the right torques here around. So in traditional HP style, it has a couple of hex nuts on the back. Let me just bring you over to, let me put the cats back in display. HP UX. I do have the I/O cables. Yes, I do. Why? Do you want them? I only got this thing for the display. The display is nice and bright, and I want to run Pong on it. So I think these are basically all the screws that you need to take off. I love the way HP always used this style of feet on their equipment, and more importantly, I love that every piece of HP test gear from back in the day had these things on the bottom. So these things are wonderful because they fit everything from a 3441 to a 3458A to the 4145 to everything in between. So they did such a wonderful job designing this surmounting system for the feet, and that they never had to do it again, redesign it. So it will always be like my favorite system for standoffs. I might need to take out a couple more screws, but I don't remember which. Oh, and by the way, I wasn't. I tried to use it as a GPIO once for unaudited test, but I could not find a way to monitor the state of pins via GPIO. Yeah, the grooves are also great for stacking. Excellent point. I have never had any problems with HP gear not stacking perfectly on other HP gear, which is just plain wonderful. And exactly, they slot perfectly into the instrument below, and it's very secure and non-jiggly. The worst ones were the brown Keithleys, like the shoe boxes. So those didn't stack with anything, and that's terrible. The newer Keithleys actually have provisions in the rubber bumpers for the feet of the Keithley on top, and I think Keysight, the Keysight rubber bumpers are pretty terrible as well. So they've gone backwards when it comes to this. This is actually a very nice design. Really, really love it. And I'm not sure if I'm supposed to take this off or not. I don't remember. Yeah. The previous guy went in here. I don't know him, but he broke the bottom, and I'll have to super glue it back together. And I think the handle has to come off as well. And that should be it. Oh, one more thing. These things on top. These things actually hold on the, what do you call it? The baggie, the carrying case for the probes and stuff. If you take the Keithley rubber bumpers off, they stack fairly decently. I actually found it the other way around. If you don't take off the bumpers, they stack pretty alright. So, yeah, it is. Hi, Mike. Mike ditched watching football in order to join the stream, which I appreciate. Very, very, very nice internal construction. So, gonna take, just look at this. This is so clever. They had two of these pins that just slot in here, and that's the only thing retaining the power supply, from the inside at least. And you can just take these out. The bottom is a big die-cast plate, and you need to take out the floppy drive in order to remove the power supply from the unit. And it comes out like this. And the power supply actually has a couple of connectors as well in here. And that's it. And that's how you replace the power supply in one of these things. And now, because Ecuador is up 2-0. Oh darn. We can have a closer look inside. So we have the main board, just basically, I think that's a Motorola processor of some description, focus, and some memory. I think that's I think this is basically the main. Why is the CRT making me feel worried? Why is it making you feel worried? I think this is the main processor for the unit, and I think this is responsible just for the digital inputs. That's all. I think that's all it's doing. This is the fan connector. The fan is pretty busted in this unit. It sounds terrible. And we have another board that just has, I think, video and a brightness potentiometer that you can access from the back for the CRT, and the filament and grids and the yoke connection. So this is basically an off-the-shelf module which controls the CRT, and I think it's also taking power through this cable as well, because it's pretty close to this fuse right here. And you have the V-Sync, H-Sync, stuff like that in there. And yeah, that's about it. That's a 68EC02. So it's a 6802 processor, the big one here. I don't want to disturb the cat cam. So the big square underneath there. And there's a Altera programmable logic device in here, some local regulation, power supplies, filtering, a buzzer, and that's about it. But just a beautiful device by itself. Very high quality components in here. This is a Toshiba CRT 68020. What is the difference between the 6802? Oh, 68K20. Yeah, you're right. That's about it. Nothing especially important in this thing apart from the firmware, so software, whatever you want to call it. So hardware-wise, this thing is very nondescript, non-interesting. It's just an off-the-shelf display module with a custom board with some processing, and that's about it. But when it comes to actually, if I could take out the how deep do you want me to go with this thing? Because I could go pretty deep in taking it apart. So I've already done this before. So extracting the display board is reasonably simple. You just unplug everything, including the tube socket and this thing, which I hope will not shock me. MMU meaning memory management unit, or floating point support. Right. So we took this out, and we already have basically 2/3 of the device free. And I'm pretty sure that if I take out a couple of screws on the back, we'll be able to remove the board and have a closer look at it as well. Come on, you and your juvenile puns, mate. Should be ashamed of yourself. Really should. Oh, by the way, it's got the same ridiculous switch arrangement as in the other HP scope that I took apart and repaired a while back. The one with the one which I forgot to clean the board for, if you remember that one. Yeah. So how is everybody doing? World is still unfurling around us. Oh, one more screw. And that was it, I hope. Yep. Oh, wait. There's a couple of cables I need to take out before I can extract the rest of the thing. More cables. You're not seeing what I'm doing. Shush. And another couple of screws. I hope the cats are being entertaining enough. I sure as hell am not. Right. So finally, I'm actually not even gonna bother putting this thing back together, because that was the main idea all along. Just taking it out and identifying what sort of video it would require. Faster, please. Oh, shut up. You troll. Right. Here, happy now? It's a bit dirty. I'm sorry. So, clock, generator. I think this is supposed to be a reasonably low noise jitter clock source. And we do have some custom input circuitry here for the digital inputs. The digital I/O is just this part here. ROM. This is the main processor, I believe, and this is just some custom piece of silicon, I'm pretty sure. It's not socketed. It looks very gold. Like the package itself looks very golden. Yeah, no way am I gonna be able to take this thing off the heatsink. Yeah, that's just about it when it comes to this this thing here. So considering this was the connector for the display, was it? Yeah. Considering this was the connector for the display, I could just readily look at the pinout and figure out which pins deliver what. And there's probably gonna be some sort of video DAC around here. Yep, that's all. Not very interesting. What do you mean this has half the channels? Were there ones with an extra board on top or something with more channels? Because I don't really know where you'd put extra channels. Maybe here? And this part here? Anyway. Right. And now for the pièce de résistance, and this is going to be it for this stream, because I don't have a lot to say about the HP. The board, that board is larger. Okay, maybe. So this is my 3458A. There are many like it, but this one is mine. It is my best friend, and I must master it as I must master my life. This again, this came from AB Precision, from the lovely Mr. Adrian Bernhardt. Now his prices are dependent on what actually you want. So the nicer ones, like this one, are more expensive. He has older ones. He even has some Agilent ones, etc., etc. If you need very good quality, uh, very, very verified, like I got a ton of paperwork with this thing. Drift was well within spec, like way better than spec. Temco, I couldn't notice it because I don't have anything better than it in Temco. So I'm not sure if this one has a new A3 board, but it definitely has new capacitors, new Schaffner filters, new everything. Option 2, high stability option as well. And it's just gorgeous. Just look at it. It's the most beautiful multimeter ever made. And now I have one. So if you get something from him, tell him I said hi. When I get the rest of the things, I'll say thank you again, of course, because, again, not a paid promotion. I didn't get a special YouTube discount or anything like that. I paid for this with my own money. I made my own financial decisions, and I'm very grateful and privileged to have one. But it's not I paid for it. But I would completely buy it again from the same place, instead of going to somewhere like eBay, because the prices for eBay stuff, for these kinds of meters on eBay, is just ridiculous. A beauty, a Bonnie, and a joy forever. Exactly. Couldn't have put it better myself. And it's actually measuring the 237, the source meter right now. And let's see, hang on. Yeah, it's been doing a lot of stuff. I don't know exactly why the standard deviation is 378 volts, but let's do that again. So I actually forgot to set the number of samples. But anyway, yeah, it's because I'm moving around it and screwing with it. I actually got this SMU down to pretty well close to 15 microvolts of standard deviation. So goes to show a naked Zener like the one in the 237 can actually be a very, very good voltage reference. Very low noise, actually. Anyway, that will be it for today. A bit shorter than usual, but short and sweet, as they say. Here, wait a second. Have a look at the cats again. Let me bother them for you. And let me bother this one as well. Pesto and ravioli say goodbye. Sorry that I didn't have any more interesting stuff. Didn't go to the flea market because it was kind of rainy, and I had more important things to do. Thank you for joining me. Have a great week. I know tomorrow's Monday again. But the year will be soon over, so Santa Claus, presents, etc., etc. Who knows what what next year holds for us? So yeah, thanks for watching again, and have a nice week, and take care of yourselves. See ya. Bye bye.